All right, so that's the ground state. To do an Sp3 hybridization, I need to hybridize all of these orbitals in the valence level. For nitrogen, the highest energy level is 2. 2s and 2p are in that highest energy level. And to hybridize to an Sp3 state, I need to hybridize all 4 orbitals, the s and 3p orbitals in that valence level. This is going to be Sp3. I'm going to start with Sp3. Okay? So what I'm going to do is I'm going to create a new set of orbitals that are all the same. There are 4 of them. We hybridize the s, we hybridize all 3 of the p's for Sp3. So we're going to call this Sp3. So this is in the second level. Because I'm an Sp3, you hybridize 1s and 3 p's, Sp3. 4 orbitals. 4. 1s, 3 p's. 1, 2, total 5 if you include 1s, but 4 hybridized orbitals. Okay, so these are Sp3 orbitals here. Okay? I go back and I count all the valence electrons. All the electrons in that highest energy level. 1, 2, 3, 4, 5 electrons.
That's what I was saying. There's going to be 5.
I'm sorry, when I was talking about orbitals, I thought you were asking about orbitals. So I put 1, 2, 3, 4, 5. I heard somebody use the term school bus roll. You can call it that. Okay? That's an Sp3 hybridization for nitrogen. Okay? All right, I'm going to do Sp2 next. Sp2. All right, with Sp2, I'm going to hybridize the s and 2 of the p orbitals. That's where we get that Sp2 from, 2 p's. Okay? 2 of the p orbitals are going to be hybridized plus the s. So 1s remains the same, it doesn't change. We're going to have 1, 2, 3 orbitals hybridized. 1, 2, 3. S, 2p, that's 3. And we're going to have one of the 2p orbitals is not hybridized.
Here you go.
So this is an Sp2, it's in the second level. Thanks. Alright, I'm going to count all the electrons. And I'm going to use that school bus rule to fill all 4 of these.
Hey, so you take on Sp2, you take the first 2 boxes off the P?
Yes.
Closer to the S?
Yes. 1, 2, 3, 4, 5 electrons. 1, 2, 3, 4, 5 electrons. Ron, that's getting a little old. All right, now we're going to do Sp.
Oh. Whoa. Sp2, and you got
All right, with Sp then, we don't hybridize the lower level. We leave that alone. But in the valence level, this second primary level for nitrogen, I got to hybridize, for Sp, I've got to hybridize 1s and 1p. So that's 2sp here. And that leaves 2p orbitals that are not hybridized. And I count all the electrons and put them in according to the school bus rule. 1, 2, 3, 4, 5.
1, 2, 3, 4, 5.
Okay. When I look at a formula, when I look at a chemical, a Lewis structure, for example, a Lewis formula for any compound containing this nitrogen, if the nitrogen has, let's do it this way. If you add up all the single bonds, or let's say sigma bonds, because single bonds are sigma, all the sigma bonds plus lone pairs, and it equals 4, that's Sp3 hybridization. You add all the sigma bonds and lone pairs, and it equals 4, that's Sp3 hybridization. Okay? Okay. If you add all the sigma bonds plus lone pairs, and it equals 3, that's Sp2. If you add all the sigma bonds plus lone pairs,
that equals 3, and that is P2. Where'd they get the letter J? Like on the periodic table?
they don't get it off the periodic table. It actually refers to something that happens in spectrometry. All right. Single bonds. Single bonds come from the sharing of hybrid orbitals and single bonds are sigma bonds. Single bonds come from the sharing of hybrid orbitals, and single bonds are sigma bonds. Yeah. Okay. Double bonds. Double bonds contain one sigma bond and one pi bond. Pi. One sigma bond and one pi bond. Triple bonds. Triple bonds contain one sigma bond and two pi bonds.
left a note inside the corner. Alone.
You left what now?
I left Shelby a note.
Okay, good.
It's a long one.
Well, that's probably nice. Okay. All right. Sigma bonds and lone pairs come from hybrid orbitals. Pi bonds come from unhybridized p orbitals.